Hello everybody, welcome again to the Beginner's Screencast series. This time I would like to show you something about intentions. So I'd like to show you ways to refactor the code or to make it easier for the user of your language to modify the code. As a side effect, you'll see some of the tricks on how to manipulate AST in intentions, refactorings, and some other parts of MPS. So let's jump right to code. But what you see here again is my simple domain-specific language for defining constants, where we define a set of constants. Now these constants have name and initializers, and they can refer one another, just like in Java, and actually this gets generated into Java, but you probably know that from the previous episodes of our series. Now what we would like to do today, we would like to allow the user to restructure, reorganize the code in this particular domain-specific language. So like if you use Java or any other general purpose programming language with a decent IDE, then you know that you can inline variables or constants, or you can introduce variables. These sort of simple refactorings that you can apply to your general purpose code. Well, we could have the same support for domain-specific languages, and that's what we'll do for our simple domain-specific language here. So the first thing I'd like to do, to start with something very straightforward, I'd like to be able to inline variables, inline constants. So since the maximum constant refers the minimum constant, I'd like to allow the user to inline this. So instead of maximum being minimum plus something, I'd like maximum to be 0 plus something. So I'd like basically to take the initializer from the minimum and replace the reference to minimum with the actual initializer. So let's do it. So minimum, the stuff that we are positioned at here, this is a reference, this is a constant reference. So we have to go to constant reference and create a new intention for constant reference. Well, we should give it a name, so let's call it inline constant. It applies to constant references, and we give it a string description, so that will be the description the user will see in the pop-up menu. So let's call it inline constant. So this is the text the user will see. It's applicable to all constant references, so no change here. Well, and here we have to do the actual transformation. So what we need to do, we need to get hold of the constant that we refer to, and take its initializer and replace ourselves, meaning the constant reference, replace ourselves with the initializer. So node, which is the parameter we get into this method, is the constant reference that the user is positioned at. So we grab the original, which is the actual reference that goes to the constant. So now we have the constant. So we need to store this in a variable. We can call it, well, let's call it original. And well, now we just replace the current node. So we replace the reference, replace with, and we replace it with the initializer of the original. So we go original, that's the constant that we refer to, its initializer, that's the expression it's being initialized with, and we'll just take a copy of it, because if we took the initializer, we would remove it from the original place, which is something we don't want. We want the original constant to remain intact. The original constant will stay the same. We just remove the current reference with the initializer of the constant. So, well, this is the whole code. So we need to rebuild. And if we go to our language, so here is the minimum. I do Alt-Enter. You see the light bulb? The light bulb just appeared. Alt-Enter will show this little pop-up of all intentions I can apply at my current position, and it provides, well, it offers inline constant. If I do inline constant, it removes minimum or reference to minimum and puts the initializer itself. So, well, if we change this to, let's say, 20, or maybe something more complex, 20 plus 10. No, inlining means replacing with the initializer as it is supposed to work. Good, so that was the first very easy step. Let's make a little bit more involved intention now. Well, to do that, I'll introduce another constant so that we have a little bit more constants here to play with. So let's call it default, which is minimum plus 50. So that's a default. So now we have 3 integer constants. Now what I would like to do, I would like to allow some sort of safe delete for constants. So when positioned on a constant like minimum at the moment, I could say, you know what, just remove that constant, and if it's being referred from somewhere, then replace the reference with the initializer. So we would be able to remove minimum and have default and maximum modified so that they use 0 instead of minimum. So that sort of intention I want. So this time it will be applied to the constant, not to a constant reference. So I go to constant, create a new intention. Well, let's call it save remove constant. Applicable to constant. Again, no changes here. Safely remove constant should be the description. It is applicable to all constants. And now we need to write code that will do that. So what we need to do, we need to get hold of all the references that refer to our constant. So node at the moment is the current constant, the constant the user wants to remove. So when we get the ancestor of type constants, which is the set of constants in which we are. So basically all the constants. So now we have that set of constants, and now we have to find all descendants that are constant references. So now we have them. All references used in our code will be retrieved, but we only need to take those that point to ourselves. So only those references where the original is us, node. So that's what we want. We'll store it in a variable called all references. All references. So now we have all references. Now what we need to do is to replace in all these references with the initializer of our constant. So we will go all references for each, and now we go it replace with, and we'll replace it with a copy of our initializer. So node initializer copy. So now all references will be replaced with a copy of our initializer. So now we can safely remove the node. So we go node dot delete. I'll rebuild. Now back to code. If I'm positioned at minimum, Alt Enter, safely remove constant, I'll remove it. And you see default, both default and maximum now don't refer to minimum, which no longer exists, but they have inlined the original initializer of the minimum constant. Now, the last thing I want to show here is an opposite intention, an opposite refactoring. Introduce constant. So I want to allow the user to select some expression or part of an expression inside the initializer and say, well, I want a new constant initialized to this, and I want to use that constant here instead of this expression. So now I want an intention that would create new constants. So let's do it. In the intentions section, We'll create new intention. Let's call it introduce constant. Introduce constants. Now the constant now it's applicable to expressions. So description, introduce constant. Now obviously it can't be applicable to all expressions, but only to those that are initializers of a constant. So this will only be applicable to such expressions. Node is the expression which have a constant as its ancestor. So we go, well, the constant, the ancestor of type constant must not be null. Must not be null. And now we need to do the refactoring. So now we assume the user has selected some expression of, part of the initializer, which is an expression. So we need to create a new constant and refer to it instead. So let's do it. So we need new node representing a constant. So that's a constant. So that's a new constant that we have. And now we need to add it to the list of constants. So we take node, which now this node is the expression that is being selected, and we find the parent constant. So now we have the constant that owns our expression, and we add a previous sibling. It needs to be the previous one, so that the new constant will be above the current constant in the list. So we create a new one, which will be the constant that we've just created. So now we have it. And now we need a reference that will point to that constant. So new node for constant reference. Now this reference needs to point to the new constant. So now the reference points to the right place. We can replace, well, the selected part of the expression, we can now replace it with the reference. So now we have a constant. Now we have a reference put in the right place, which points to the constant. So far so good. Now what we need to do, we need to set the initializer correctly on the new constant. So the constant needs an initializer, obviously, and it should be, well, the selected part of the expression. Now here's a question for you. There's one thing missing. We set the initializer, but we omitted one important element of constant to set. Well, the name. Right? We never specified the name for the constant. We didn't give it a name. That's because we want the user to specify the name. We don't know what name the constant should have, so we leave it empty, and we rely on MPS to highlight errors or missing information and let the user to specify it. So let's do it. Let's see what happens when we build and test our intention in code. So now I go to constants. I've got a piece selected. Alt enter, introduce constant. Here we go. Now the constant has no name, so I have to give it a name. But here it is. That's the constant that we were that we just introduced, and now we can safely remove that constant, and things are back to where they were. If you can select just part of it, you don't have to select the whole initializer, just part of it, and say that you want new constant for this. However, notice the inconvenience that we currently have to live with, and that is that we can't start typing. You know, the cursor is positioned on the wrong place. That's a little annoyance, and we're going to fix it now. So back to introduce constant. Now we'll take the editor context and we go select, well, and we indicate what we want to select, which node. But obviously we want to select the newly created constant. So we're getting there. So now we will have the constant that the newly created constant will be selected. So we get at least closer to where we want to be. So introduce constant, good. Now, but now the whole node is selected, and when I can start typing. So now, you know, things are definitely better than they were before, but still not perfect. I would like the selection to only, so introduce constant, the selection to only, you know, highlight the item that I'm going to edit, which is the name. So the last thing we need to do, instead of select, we go select with respect to the focus policy. So now it will kind of take the editor, and based on its focus policy it will highlight the elements that are focusable, and we need to update that. So we need to go to the constant, editor, take name, and say that it attracts focus. So this component attracts focus. Well, that should be enough. So now this, you know, this editor cell being focusable plus the selection with respect to the focus policy will be enough to put our cursor and selection on the particular editor cell of a particular AST node. So now I do introduce constant, and here we go. So the editor, when is positioned right there, so I can start typing name of the constant, and we're done. So now we have 3 new intentions added to the language. One of them is to introduce new constant. Another one is to get rid of constants. Well, and the one we created at the very beginning, the most straightforward, just inline constant, which will insert the initializer of the original constant instead of the reference. Okay, that's all for today. Thanks for listening. Goodbye.